Your captions lag because you wait for final results. The fix is rendering partial recognition events instead. Azure AI Speech streams interim text roughly every 200 to 300 milliseconds. This video is for engineers wiring live captions onto a stream. We dissect one reference architecture end to end. 3 parts: the audio pipeline, the recognition loop, the overlay sync. One part hides a gotcha that doubles your latency. Here is the whole system on one diagram. The video source feeds 2 paths at once. One path extracts a raw audio stream. That audio flows into the Azure AI Speech service over a push stream. Recognition events come back and hit a caption formatter. The formatter overlays text onto the video frames. Key vault holds the speech key, never your code. Every arrow here is a place latency can hide. The audio path is where beginners stumble. Azure Speech wants 16 kHz, 16-bit mono PCM. Your stream is rarely in that format. So you decode, resample, and downmix first. FFmpeg handles this in a subprocess cleanly. Then you push chunks into a push audio input stream. Small chunks, roughly 100 milliseconds each, keep latency low. Send 2 large chunks and interim results stall. Here is the core wiring in Python. You create a recognizer over the push stream. Then you subscribe to the recognizing event, not just recognized. Recognizing fires for partial results as speech arrives. Recognized fires once a phrase is final. Start continuous recognition and let callbacks drive your overlay. This is the whole engine in a dozen lines. Here is the gotcha I promised. Speech recognition runs behind the live video. By the time text returns, frames moved on. If you overlay immediately, captions drift ahead of lips. The fix is a small video delay buffer. Hold frames 1 to 2 seconds, then composite. This aligns spoken words with the caption text. Test the buffer against your real end-to-end latency. Real streams break, so design for it. Network blips drop the WebSocket to speech. Handle the cancelled event and reconnect with backoff. Long silence can end the session early. Segmentation timeouts and keep alive audio prevent that. Watch your quota. The standard tier throttles concurrent connections. For high volume, request a raised limit ahead of time. Buffer audio during reconnects so you lose no words. One architectural decision remains. Run this in container apps or on your own machines. Container apps scales per stream and handles TLS and secrets. Self-hosting gives tighter control over the FFmpeg pipeline. For most teams, container apps wins on operational cost. Reserve self-hosting for specialized GPU encoding needs. Pricing and limits shift, so check the current Azure docs before committing. Pull the threads together. Partial recognizing events give you responsive captions. Feed clean 16 kHz mono audio in small chunks. Buffer your videos so text and lips align. Plan for reconnects, silence, and quota limits. Get those for right and the overlay feels instant. Try building the recognition loop first, then add the delay buffer. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.